Okay, now here's a puzzle that you may have been wondering about from the very beginning, because we used credit analysis as our sort of concrete example, our concrete example that went through the whole course. Okay, and we illustrated all the concepts in this credit example. So here, I give you an applicant with age, gender, salary, and so on, and I'm asking you to determine whether or not to give credit. Okay, and banks have lots of data, and all the customer information is there, and they know whether or not they defaulted on the credit. Okay, so think about it a couple of seconds. This is the puzzle. Where's the sampling bias? Okay, and 1, 2, 3. If you're coming back just for the ride, the sampling bias, whether or not who defaulted on their credit. And you can only default on your credit if you were given credit. So they actually have only got data on customers who were approved for credit, and then you can look and see, did you or did you not default? Sampling bias, just like filtering into the PhD program, filtering the monkeys from all the animals, and so on and so forth. Okay, sampling bias. You have one bin of data, i.e. those who have been approved for credit, from which you're trying to learn, but then you're going to try and deploy this system on all customers. Okay, now, in some sense, if the approval of credit was reasonably lax, then it may not be such a bad situation here, because there are those who were approved who are clear approves, and they don't really affect the decision boundary. And then there are those who are rejected who are clear rejects, and they don't really affect the decision boundary. But and then close to the boundary, maybe they were a little bit lax, or their approvals were a little bit more aggressive, and so they approved a nice band around the decision boundary, and that band is all you need to get a good decision boundary for deployment of your system on all customers, because that band is still going to reject all the clear reject, it's going to approve all the clear approvals, and then you've done a good job of filtering out or figuring out what to do with the boundary cases. Okay, so it might be okay, but let me give you an example where it's a complete disaster. Imagine if their original approval system was perfect. So everyone who they approved was a good credit risk. Now you learn from this data, and your machine learning algorithm looks at this and says, for all inputs that I've seen, they were good credit risks. And so the simplest, hypothesis that fits this data is the one that just says approve everyone. Now you go and implement this on all applicants, and it is a complete disaster. Okay? So that is just to show you that when there's sampling bias like this, things may be okay, they may be a disaster. It's just that all bets are off. We have no idea. Now, I'm going to ask you another question. Okay. How could you use the system that's learned from this kind of data? How could you use it? I'll give you a few seconds. Okay. Think about it. Pause the video. If you're coming back just for a ride, one way to use it, okay, is to say, well, I can't use it on all people. So I'm only going to use it on the bin that I trained on. So you can use it as a cascade, which you can put on top of the original approving algorithm. So what you do is you say for the bank, listen, what I'm going to do is I'm going to improve your system. So give me the data from your system, which is all the approved customers, and then those who defaulted or not among those. And I'm going to learn how to fine tune. And then what we're going to do is we're going to use your system and then my system. Now, if your system was perfect, my system will just approve all the things that went through your system. If your system was not perfect, maybe I can fine tune and do better. Okay. So that's one way in which you can use this data to improve the system. But then you're going to lose, all the people who were rejected, who should have been approved. And if there were biases and historical issues with who got credit and who didn't, that could lead to severe, societal inequity. So this is a very challenging problem. Okay, how to deal with this sampling bias. Okay, so